Okay, so my name is Pankaj, and I have almost 30 years of experience in cybersecurity and on OT security perspective, also in previous organization like Wipro and Tech Mahindra. So I worked on OT security solutions as well as building IoT security solutions as well. So from that perspective, I have knowledge about the industry and the challenges also what customers are facing and what kind of problems and what kind of solutions also that we are preparing for those kind of customers. Because once you go to global customer, they had like different variety of challenges. Every industry has different challenges, and more or less those are common at a high level. But yes, once you get detail into those things, yes, there are different pockets of solutions which can come. So from that perspective, I'll just taking this session, so just about the context, and with that we I think we can start the presentation.
Pankaj, would you like me to introduce myself?
Yeah, you can introduce now, or maybe you can introduce your session, but better you introduce now itself, I think.
Yeah, so thanks. I'm Chitrang Srivastav. I'm a core OT security person. Started my journey as a core OT guy with over an experience around 19 years. I'm heading the OT security practices for Nara Energy, and I've done lots of transformation in my previous organization in the critical infrastructure. Has an experience of building up the OT security policies, deployment of defense in depth on OT systems, and pioneered on a lot of solutions in India. So this is somewhat about my previous background, and I'll be collaborating with Pankaj in taking you through this OT security fundamentals journey. Thank you.
Thanks, Chitrang. We can move to next slide. So this is the agenda that we crafted as I was working with Chitrang, basically. So we don't because the subject is huge, right? So we just want to cover basically what are the key components and what are the key concerns, right? So that you have some practical kind of scenarios also and how things work, right? So we have factored this understanding of OT environment so that you are aware of what is OT environment and how does it differentiate with IT environment. So what are the different tenants of OT environment, and what kind of incidents which have happened in OT, and what kind of incident can happen in OT environment, and what kind of security risks which are there in OT environment. And then comes basically OT network architecture. How does it work basically? What is Purdue levels 1, 2, 3, 4, 5? So because typically in OT those kind of terminology work, right? So that's just a brief about those things. And then on the OT GRC overview on basically how the governance, risk and compliance is slightly different than IT GRC, even though some components can be common, but there are different roles and different responsibilities that comes in the OT environment. So those are things which basically from IT perspective we need to understand that those aspects also, so that whenever we are doing the OT conversation, so at least we have those things on the back of our head. Can move to next slide. Yeah, so this understanding of OT environment. So this is yeah, we can move to this is the first section. So this is industrial control systems. As you have seen, basically industrial, you would have seen like industry 4.0 and those kind of things which is like which came sometime around 2016 2017. But before that also industry 1.0, 2.0, 3.0 has been over there since ages. So it's not a very new concept that came all of a sudden, because industry 1.0 was like sometime around 1800 when the machines started, when people moved to machines basically, and at the end of 18th century when all these network, telegraph and those kind of concepts started coming, which started integrated those machines, which was initially being driven with human only. So those kind of network comes, and then Industry 3.0 emerged after World War II, sorry, World War II, and that's where basically the digital came, right? Boolean on those kind of numbers came, and then basically more digitization of these things started to come, and it was happening till 2016, 2017, where Industry 4.0 came, where whatever you could do, you had done with those machines, technologies, everything. But in Industry 4.0, it's a digital revolution where it's more of like automation kind of thing. So the concept is basically whatever work is repetition work, and whatever can be done through computers, let's deploy computers to do those things. So you would have seen like a lot of robotics and smart factories, smart machines, so everything coming after that. And beyond that also, basically once you have get into the smart industry, then digitalization and artificial intelligence, machine learning, all these things basically complement each other, so that basically the output or the outcome of these Industry 4.0 gets multifold. So if any industry who is still on legacy platform and those things, the push is basically to move to Industry 4.0, so that they can also reap the benefits of new technologies and AI, ML, those kind of solutions. So it's a combination of hardware and software basically, and the screen that you see on the front it's a screen that if you go to any of the manufacturing plant or industry, you will see these kind of screen. This is basically supervisor control and data acquisition or SCADA system that you see, and behind that basically entire machinery works. So behind that, this is SCADA, which gives you basically entire reading, basically from if it's a gas flow, basically how much gas is flowing, what are the reading of every point, basically if it's a temperature sensor, so what's the sensor reading, it's a motor revolving, so what's the reading of those motors happening. So everything basically you see on this SCADA screen. So it's like you can consider it's like knock kind of or sock kind of screens, where you see like complete visibility of what is happening in my entire plant. And behind that, basically next level comes the PLC, which is like program logic control, which converts these electronics, these signals into the next level of signals. And after that comes the field devices, which is like your actuators or motors or those kind of, or valves, those kind of, which are like physically systems or machines, right, which actually runs physically. So then that kind of level comes. So so this basically gives you entire visibility of basically what is happening on the plant, right? So yeah, and you will see like these things across any industry, OT plants. So you will see these kind of systems. So we can move to next screen. So this is a simple because from OT perspective, you will see OT everywhere, whether it's power generation plant and whether it's oil and gas facility, because everywhere you will see these PLCs, SCADA, these systems will be there everywhere. Healthcare will be healthcare also. You can see even in the hospital also, you see like a lot of X-ray machines, ultrasound machine, MRI machines, right? So a lot of machines are there, and everything is connected also. They have like separate LAN also. Sometimes they call it hospital LAN, but eventually everything is controlled through computers. So that's why all these are eventually OT system itself. And there are solutions also like Internet of Medical Things, those kind of things, which prevent those, which secure these systems. And then on transportation also, you have seen like shipping is a big industry where like it's like 100 of containers they transport, and once it comes to port, basically then you have to move the containers here and there. And now you would have seen like everything happening automatically through the robots basically. So it's without any human intervention. So you just on the screen you just tell this from start point to end point. So it's like automatically robots and cranes so who do the entire pickup of the container number, everything, and scan it and then keep it in at the particular bay. And then in chemical industry also similar to manufacturing, so all those readings, everything basically composition being tracked through these OT systems. And then in pharma also similarly, pharma is also all these industries you see. So you will see OT systems in place. Smart city also another example where a lot of hundreds of CCTV cameras or Wi-Fi controllers, Wi-Fi, everything is there, right? Smart things are there, so everything is in control through this central console. And then BMS, another example, like a lot of malls are having now building management system where everything right from the elevator, escalator, everything's run through automatically, right? So everything is being controlled. So that's why wherever machine is controlled by technology, that's why we call it a OT system, right? So just an example. So yes, we can move to next slide. So this is some misconceptions that are there from OT system perspective, because as people see like OT, because most of people like who are working in IT, so they would have seen like when people are talking about OT system, OT security, and they see okay, something new has come suddenly from Industry 4.0. But as I was explaining, it's not something new. It's there since 1800, right? So it's not something new. It's there. It has been there, and only thing is because there were no attacks and there were other scenarios. For example, air gap systems which were there, right? So earlier air gap was there, where there was no need basically for any industry or manufacturing facility to connect to internet or even their corporate network. So that's why they are running in air gap facility. So they were secure and nobody was able to access, and even if there is any hacker, but they were not able to access the facility because it was completely air gap. But down the line, as you have seen, like industry is moving toward Industry 4.0 and a lot of new things are coming. That's why it becomes inevitable that you have to connect to internet some way or the other, and that's why all these problems starts coming. And another misconception is that IT security suffices the need of OT environment, while it thinks that OT environment might be having same PCs, computers, everything, but it's not the right thing, because even in OT, if you go to OT environment, even the protocol itself was different, because in IT, what we see only TCP/IP, TCP/UDP, HTTP, these kind of standard protocols. While if you go towards OT, they have like 200 plus different protocols. So except this TCP/IP, these protocols, though they have DNP, they have Profibus, they have Modbus, plenty of protocols, and on top of that, every manufacturer is having its own protocol also, which are native to him. So even if you put any technology like NDR or network detection or anything like that, so it will not be able to understand what is happening, because it's not the IT technology is not meant for OT technology, and it cannot understand basically what is happening, what kind of traffic is flowing. So the visibility will not be there. So those are the things which is different in OT environment. And other thing is OT security team can think that yes, they can take care of OT networks and OT security, which is not exactly true, because the way things happen in IT security is different in OT security, because in IT you have all the tools and technologies and the speed as well, right? While in OT, so that's not the, because first of all that technology, even if you bring some technology, you don't know basically what impact that technology can have in OT environment, because even if you say like vulnerability scan also, like which is like very common in IT environment, you can say okay, I can just run the vulnerability scan and find out all the vulnerabilities. But it can be as devastating that you just run a vulnerability scan in an OT plant and the entire plant can be shut down, because it has very sensitive protocols which can even like you just ping and that it can bring down the system itself. So that's why you cannot do the same thing in OT environment. So that way basically you have to have complete knowledge of OT environment, what is machine, what is protocols, and then only basically you can take that call. So these are basically typically myths basically that which comes to our mind basically why OT is so different. So just explain that, and with that I think we can move to next slide. Yeah, so this is another thing why to secure OT system, as so far it was air gapped environment and nothing was happening, but now it's not no more a air gap, and you want it or not, but still you have some connectivity or the other through the internet or the external network or the external world. So that way you have to secure OT systems. And in OT basically reliability and availability of operation is most important as compared to IT. You see like because if the plant goes down for like 1 hour also, it's like huge business impact that happens to the plant. So that way reliability and availability are the key concepts, and then safety also basically. It's not just the system will go down or plant will go down or plant will misbehave, but it's the like human safety also, because like they're like high temperature furnaces, everything's running right, and any damage, anything that happens, and there are human also who are working in the plants, because even if the temperature goes beyond the limit and it can blast some furnace, there is a loss to human, and there can be further impact also. For example, if a power grid so that's there and that goes down, and then you don't have power, so basically it's a ripple effect also, so that can also damage basically. So it's very devastating. And environment also, as you say, like uh, you have seen like oil leakage, BP attack that have BP oil spill that happened right in I think 2010, which is like Deep Horizon. So that kind of attacks can happen where like it's a huge like oil spill, and a lot of environment damage can happen, which basically you cannot easily revert those things, right? Not like IT system, okay, you can just restore the backup, everything's back to uh, operational. So it doesn't work that way, because the impact is huge. And then the regulatory compliances, if you say, those are stringent regulatory compliances, stringent hefty penalties which are there on these industry, and every industry is bound with certain clauses, compliance in those kind of things. And business impact, as I was saying, it's a huge business impact, so you cannot compare with the IT. And reputation also, because once you have these kind of attacks, and then basically it's reputation goes for a toss basically, because it's a huge, right? So this is just yeah, coming next slide. So basically the challenges I was securing, because it's insecure by design. For example, in IT that you see like HTTPS is there, you have secure FTP, secure protocols, everything that you will talk about security nowadays, right? Encryption, everything. But is it possible in OT environment? No, because protocol doesn't understand what the security is at all, right? So, and then persistent legacy system. So the lifespan of OT system is like 20 to 30 years, while in IT it's like just 4 or 5 years. Every 4 or 5 years the OS, everything gets changed, right? So that way it becomes very difficult. And protocols also, I was telling that 200 plus protocols, and every vendor has its own protocols proprietary. So it's very difficult even for patching also. Even if you do some vulnerability scan, you find some vulnerabilities there in the firmware, but you cannot patch those easily, because you cannot patch on your own. You have to work with the vendor, you have to ensure that patch is there, they have the patch and they work on the patch and then apply the patch. And even applying of patching also not easily, because you need certain shutdowns also. And in OT industry, shutdown never happens, because all 24/7 are running industry. And to shut down also, like even if you take like 5-10 minutes of shutdown, it's like a huge impact to them, because it has ripple effect of multiple supply chain and everything. So that's why taking shutdown and apply patches, it's not that easy, and the risk is always there. So that's why that's the huge difference between how IT works and how OT works. And then the network architecture, like it's different network, different protocols, switches, everything is different. So not like IT environment where it's easily you can detect, because first of all the problem comes in OT, basically the visibility. So in IT, if you see, so if I ask you, any of the CIO, any of the CISO, how many assets you have in your environment or in your CMDB, so he can easily tell, okay, I have these many assets with maybe 5% here and there, but they have that clear idea of basically how many assets are there, working assets are there in my environment. But if I go to any OT facility and you ask basically how many assets you have, so nobody will have any idea basically how many assets or how many IP assets they have. So that's the main problem, because the visibility doesn't exist at all, and there are no solutions also which can provide this kind of visibility, because some machines may be working like once in a month kind of thing, so some cycle it happens, so those kind of things, that's why they don't have visibility. So that's why even I've seen multiple customers who come to us, basically one of the customer who are having like mines operation across multiple countries, so they don't have any visibility how many assets are there, how many active assets are there, so they don't have any visibility on those things. So those kind of problems that comes from the industry. So how to increase that, how to increase the visibility, how do I know what kind of assets and what kind of vulnerability, because to find the vulnerability, first is you have to find the assets, and once you find the asset, then only you can see, okay, these are the vulnerability, those exist in these assets. So that's basically the first step. And if you see the industry, only 30% of the industry, if you see, has gone towards that path, and who has some visibility of the environment, that how many assets and what kind of vulnerabilities are there. And if you say 50 to 60% of the industry, so they are just thinking and they are just not able to decide which way they have to proceed further. So that's the challenge that we see in OT security or OT environment, where 50 or 60% of the industry is still thinking, and they have yet to take some measure to get into this stage. And 10% of the industry is only industry which is, we can say it's mature industry, which has like full-fledged, everything is configured, connected, and they are mature. Then moving to next slide. So these are the typically differentiators, as just a brief about that. So main thing I'll just tell about security triad. If you see the middle one, which is like in OT, it's safety, availability, and reliability, as compared to CIA trade that you know in security perspective, right? So this is the key differentiator which is there, and we have to focus everything on these three aspects. So that's the main component here. And yeah, I'll not go much detail into these things, because yeah, I think that you can read. So next we can go to next slide. Yeah, so yeah, next slide we can go. So this is some of the OT incidents. So you can, because we don't have time, because if we explain like any one of these, like these, so these itself may take like every incident will, it's like a new story itself. Like it's Stuxnet was the eye opener, which impacted the Iran nuclear facilities, and how it happened. So it's a very nice story you can find on the internet, and other colonial pipeline which you had seen recently, and then the attacks which are happening. So every attack is very interesting. You will see like how devastating these attacks can be, and what kind of things are happening. As you see, we are moving toward 23-24. The number of attacks have increased. So in total, it's like more than 100 attacks which have happened so far in this OT industry. So just to give you the glimpse of how things are happening. So now I'll request Chitrans to go over next slide.
Thank you, Pankaj, for giving the introduction over the OT security. What is actually OT? If I'll say in a very layman way, any automation you see around yourself is an OT. Probably a car, the lift you use, the factory you see, that water treatment plant, whatever you see nearby is itself driven by some or the OT component. So OT is a new word, traditionally called as either industrial control systems, and OT is a bigger word in which we have different components now encapsulated, which are not actually in industrial control systems, but then there are some or the other automation solutions which are helping us in solving our day-to-day problems. So I'll deep dive into the ICS architecture. This is a typical industrial control system architecture. On the left hand side, if you will see, it is a traditional industrial control system architecture. Probably many of you may be finding it as a very new stuff. So you can see some green color devices with antennas there. So these are the main process sensors deployed, and then they give the signals to the main brain of the control network. So that is called as a PLC, or a distributed control system. So basically this like a human body, we have 5 sensors, and our brain takes all the actions. In the same way, all these control systems have the processors, and they process the signals which they receive from the physical plant environment. It can be temperature, pressure, humidity, levels of various physical processes, and then they can do all sort of computation and display it in their own format with the help of their own protocols on the human machine interfaces, which looks like a workstation, typically IT workstation, but actually the thing is happening inside it is very different. And on the right hand side, if you'll see, a secured layered architecture has been curated into the ICS environment. So now, because of this, as Pankaj explained, typically with the emergence of 4.0 requirement, and as well as globally the attack vectors has increased. So the myth over the air gap has been is now gone. So nothing is secured if you are not putting up a right kind of infrastructure in your industrial control environment. And then this is an architecture which can be connected. I referred it from a reference architecture called as a para architecture, para model, or Purdue model. So here, if you'll see, we have level 0, level 1, level 2, level 3, DMZ, level 4, and level 5. So this is a layer segmentation which ensures the data flow from the 0 level to the level 4. If we want to converge, the IT/OT convergence happens. Probably we need to have a IDMZ, industrial DMZ, between the OT and IT. The other way is to use certain deterministic devices which are stronger in their own way, like data diodes. So data diodes are very strong products which are designed to have a unidirectional flow, so that can be leveraged and over the point of convergence to send data from one point to another point in the architectures. So if you'll see that layer 3, layer 3 is not actually the main plant operational control network, but layer 3 is a supervisory control which hosts many of those supervisory controls over the control system layer. It can also host the cybersecurity solutions, which are tailor-made to understand the industrial control environment. So I won't go deep into this architecture, but you can differentiate between the left and right architecture, which is a traditional industrial control system architecture. And if you are going to connect your industrial control architecture directly to the internet or directly to your corporate networks, there can be a chance, there is a possibility, high probability of malware intrusions from the IT environment to the OT environment, and such incidences have already happened in the past, which we have seen in the past slide. Please move on to the next slide. So, coming back to the security framework, so when it comes to OT security, typically there are few things which we can do, but then there are few things we cannot do, and then we will have to live with it. As Pankaj explained, there are a lot of legacy systems working into the OT environments. Probably you may not be able to patch them as well. So, and even if you have a Windows 10 machine or a Server 2019 machine sitting up in your OT environment, you may or may not be able to patch that machine, because that trusted patch has to come from your product OEM, and it has to be validated and smoke tested in their environment, so that you get a confidence that once you upload that particular patch, your system can work smoothly. Now, for updating those patches, that is again a bigger activity. You cannot do it online. It requires an offline migrations, offline updates, and there are a lot other challenges which actually is not visible in the IT environment. So, so there are certain solutions which can be implemented, and which can be implemented in the OT environment as a strategy. We call it as a defense in depth strategy. So when we talk about defense in depth strategy, a layered security approach needs to be taken for OT environment, probably deploying the endpoint security solutions, strengthening the perimeter security using next generation firewalls or data diodes. I mentioned, look for the possibility of creating a backup solutions, and identity and access control management. Now, probably you cannot do that access management through your IT network. So IT network cannot be used to do an access management for the OT network. You need to have an independent access management network for OT, and OT. The secure remote access from IT network or from the third-party vendors to the OT networks again need to be tailor-made. It cannot be a traditional secure remote access solutions which are available in the market in terms of the IT environment, because they do not understand the protocol. They will not allow, and it becomes very difficult to fit that solution in the existing architecture. So there are certain solutions which are being tailor-made and customized to work in the OT environment. Typically, network segmentation, as I explained in previous architecture, each network architecture will be different. A power plant network architecture will be different from an oil and gas, and within that plant as well, you may have n numbers of OT networks, which may differentiate from each other. So the requirement of each and every OT environment will be different. The related risks will be different, and your network architecture or segmentation drawing need to address this. That is where you need to understand what is the actual process happening in the system, what kind of protocol is happening, how the power plant is building up the steam, what are the components which are getting integrated and getting affected if I change the position of a particular device. So all those detailed analysis needs to be done, understood. You at the same time, you need to understand the particular network related to the OEMs. So it's not like that we have a single similar strategy for all kind of a network. So probably OEMs from Honeywell to ABB, Rockwell Automation, all of them have a varieties of networks, and all the networks differentiate from each other. They have their own different requirements, and probably those solutions which we want to deploy as a part of a defense in depth strategy needs to be tailor-made. Pankaj talked about that visibility. So visibility is a very big concern. In a plant, you may have hundreds, thousands of assets running for more than 10 years, and probably you may not be knowing what is the exact data flow. Probably the drawings may not be updated. So there are certain tools which may lot of time to get integrated into your environment. They use certain machine learning models, and they learn your complete environment over a period of time, maybe 3 months, 6 months. The larger is the learning period, the better is the output of that visibility will be. So it takes those solutions are there in the environment which can be deployed in the environment. Typically, OT incident response plans. Again, these solutions are OT incident response plan and the OT SOC. Again, this is a very difficult subject. As of now, it's a very new subject in terms of OT environment, because of the challenges. The kind of protocols which are being used in the environment are different. The communication methodologies and the kind of actions happening in the OT environment makes it difficult to analyze whether it is a legitimate action or it is an illegitimate action. So there are a lot of things happening in the environment. Policies and procedures. A dedicated OT security policy is very much required in an organization which are totally focused on manufacturing setups, because a focused OT security policy will create a difference, and it will give an organization a strategy to navigate in a right way. So probably that policy needs to be tailor-made according to the industry or the plant or the manufacturing facility requirements, and that needs to be realistic in approach. It cannot be a traditional IT security policy, and we cannot expect it to get it deployed 100% within the in the environment. But yes, there's an approach, and gradually with the policy we can move ahead and try to build up those architectures for try to build up those policies and procedures and work around it. Next slide, please. Next slide. So OT GRC, no, I mean this is a very important subject. OT GRC concept is very important because traditionally it is widely understood that GRC for IT will remain the same way. I mean, in the same way the OT GRC will work, but actually there's a lot of difference when it comes to OT governance, risk and compliances. So we'll discuss in few couple of slides what is GRC. So basically governance, we understand it refers to the structure, processes and practices used to consistently manage and ensure safe, reliable and high availability of the ICS environment. Now here the focus area, when we see in comparison to IT changes where it is a CIA trade, here we talk about the safety, reliability and the availability of the industrial control environment, and the complete governance structure needs to be designed in such a way that it caters the need of the manufacturing facility. So a typical OT cybersecurity processes, they should include a dedicated OT security policy. The roles and responsibility of the individual needs to be clearly defined. OT cyber risk needs to be identified and addressed properly, and the compliances to legal and regulatory requirements in terms of OT security needs to be addressed. So these are four prominent factors which are being focused at the governance level, and a dedicated OT security governance model will help an organization to focus on these four prominent aspects, because the more you deep dive into the subject and more you put a focus on the particular aspect, the better you can improve on this on particular aspect. So here typically having a dedicated OT governance model will help to create a right kind of structure in terms of the OT security management program. Next slide, please. Next. So this is a typical OT governance roles and responsibility. So here you can see something around 9 different roles. So I'll start from the center. There should be an OT steering committee. Now, the role of our OT steering committee is to set strategic directions in terms of OT security, evaluate and the assessments and which are regularly being done for the OT, and define the road maps. What is next that has to come into the systems? Then he has to oversee, the OT steering committee needs to oversee all the activities which related to the OT security program, and they need to participate on a regular basis, maybe monthly, weekly, bi-monthly, depending upon the organization needs. So some of the members of the OT steering committee, they come from the maintenance team. So head of maintenance, head of engineering. Now there are different functional heads which are actually asset owners for the OT systems. Like if you'll see in a plant, head of automation or the instrumentation is responsible for the OT networks. Similarly, electrical department is there. Now they are also an asset owner of a bigger chunk of OT networks. The station head or the plant head will again join together, and it will be supported by a head of OT security. So you need to have an OT security head in your organization who will be the main driver of all these security programs, and then you can invite CIOs and CISOs as well, so that they can collaborate all together and support the organization in building up a complete OT security program. So I'll go to the next one from the asset owner side. Who is asset owner basically? So when it comes to OT, there are different heads. So like in IT, you have an IT head. In OT, you have head of electrical, head of instrumentation, maybe head of some digitalization probably, and head of automation. So these are the asset owners who are functionally responsible for the operations of these people. Now, ideally, when you see the organogram, these heads have a larger deliverables, and the area of responsibility is huge. So normally they have deputies under them who take care of their particular zones or some particular areas. So that the deputy asset owner is responsible for managing the risk in the OT environment. He understands the OT environment, he plans for the resources, and sees overall responsibility and accountability for individual section of the plant. And then an OT system in charge. Now the OT system in charge is a person who is an expert and technically he is expert and sound in the OT system management. He has worked into that system for ages. He collaborates with the OEMs, bring up the technologies and get them deployed into it. But he also ensures that security of their systems are also intact. One major problem when you come with this model is lack of cyber security knowledge among the OT systems, OT team. So there can be a formation of a OT cyber workforce team which have a skill set of which have people who have a skill set typically from the OT side. They understand the OT systems, how they process, and they understand the cyber security requirements, and they maintain the day-to-day activities like patching of those systems, how to take the backups of the OT systems, management of the assets, reporting to the OT asset in charge in terms of any incidences, altogether responding to the findings of from the SOC perspective. So all those actions these are people who are from the maker side, and on the checker side, you need to have a head of OT security. Now he will be the person who will be overall responsible for the program. He will perform all the review and monitoring of the of the OT security compliances, oversee all the OT GRC, SOC activities, and OT security administration, collaborate with the asset owners, and help them, advise them time to time on what are the best practices, bring up new solutions, and help the asset owners to get deployed. Similarly, there are different roles like as OT GRC lead. Now, so he will be responsible for taking care of the complete GRC piece of the OT environment for that organization. Now, depending upon the size of organization, the numbers can increase. Probably you can have one lead and 2-3 sub leads or support analyst, whatever it is. Security administration guy is again reporting to the OT security head. So, and then we have an OT security operations manager. So he will be taking care of the OT SOC piece, and he understands the OT networks. He understands the typical OT security solutions which are responsible for asset visibility of the OT environment, and vulnerability management, incident responses of the OT environment, and helps the OT team to respond, to take care of all the responses happening in the OT environment. So this is a checker team, and this is the team of OT security head who will be overseeing the complete program from the top, and they will also collaborate and support the maker team who will be responsible for making this complete implementation of all those solutions. So, for example, there is a plant which has a bigger number of organization having big number of plants or facilities. So, probably different plants can have a different sets of local teams who can collaborate with the checker team who is governing from the group level, and the steering committee can be a collaborative steering committee, because any program which runs on a group level will pass on to all the facilities in the same manner. So the group team can help the local teams or the local makers in bringing up right kind of technologies, help them in defining the right kind of, taking care of right kinds of roles, and help them in day-to-day activities. So this is a governance model which is very practical to be implemented, and this is much needed kind of thing, because when you want to give a focus on OT security, you need right kind of people in the ecosystem who understand the subject, and then they can bring up lot of things in the environment to enhance the capability of that environment. Next slide, please. So these are certain benefits when you have a strong OT governance, like clear strategies are defined. No, it facilitates secure data flow, from information flow actually, from down to top, and it helps the organization to take right kind of a decision. It helps the OT team to implement right kind of secure architecture, build trust among the stakeholders, protects the values and reputations of the business, and as well as aligns the organization to the compliances, because a lot of compliances are coming up globally, typically in India as well. As if now we have CEA guidelines, no, but there are many more guidelines coming up from different sectors for securing the environment. So it will be a very crucial step to think about the governance for a piece when it comes to OT security, because that is a starting point. If you want to run a strong security program, you need to have a right kind of a governance structure with right kind of people playing a vital role in building up the roadmaps for secure, smooth, and resilient cyber journey for operational technologies. Next slide. So OT risk management, definitely everyone understands the risk management, but when it comes to OT risk management, the focus totally moves towards the safety of the environment, and it moves towards the safety of the people and the plant. It moves towards the environment and health, as well as it moves towards the focus moves to the availability of this of the OT environment. So typically an organization is far more vulnerable to security incident and safety incidents and potential operational disruption in the absence of OT risk management. and OT risk management, it can create life-saving scenarios, no, and it can prevent any chain reaction. So normally what happens, any incident happens in one part of the plant, probably it can impact the other section, because all the processes are connected. It is not about only tripping off that particular plant for a particular instance. The slide has moved. So anyway, so it is not about it's not about only tripping off that particular plant, but then there are some the processes are happening. So for example, let us assume steam is flowing through a particular pipeline. One portion of the plant cuts out. What will happen to that steam? It has to vent out. Probably otherwise, if the temperature is very high, it can burn the is very high, and if the pressure is more, and the pipe is not capable enough to take that load, probably it can disrupt that pipeline, and once the system breaks, it may take days, months, whatever. So it's an example of a pipeline, but it can happen to any part of the system. So that is where OT systems are called as a cyber physical systems, because it's not about we are dealing with protocols. It's not about we are dealing with switches or computers. It is about we are dealing with plant physical processes, the temperature, the pressure, whatever things. So all the risk assessment of an OT environment has to be done considering safety, reliability, and availability. Otherwise, there can be potential impacts which will be irreversible in nature. It can bring a station or plant down for maybe 2 months, 6 months, year, or the condition can be like your plant will never start. It can cause an impact to the environment, where the leakage of potentially toxic gas can kill thousands of people who are living near around. So it is something which is very serious, and the assessments needs to be done totally in that perspective. Next slide, please. So there are three major components when I see OT risk assessment: identifying the asset criticality, understanding the impact, threat vulnerabilities, and vulnerability identification. So asset identification, as I mentioned earlier as well, it is important to understand in which process that asset is deployed, and identification of critical assets within the process. So first you need to understand in your plant which is your critical process. Okay, if you identify this critical process, there will be certain critical OT asset sitting in that particular process. You need to identify that asset, and then identify it as a critical asset, less critical asset, whatever it is, depending upon the way you classify your assets. The impact factors needs to be calculated over safety, environmental, and production or availability losses. So you don't need to calculate things basis confidentiality, integrity, and availability, because these are the main factors. Safety is paramount, and then all the impacts needs to be computed basis these parameters. Threats and vulnerability identification is, again, each network, as I mentioned, is not same. Every network can be unique. So you need to understand and identify the lacunas or gaps in the networks. So for understanding that network, you need to understand the OT protocols, how the OT environment is navigating in terms of data flow, and what are the key components in this. Identification basis process adapted in the OT environment. So again, this is another point which needs to be focused, and then threats and vulnerabilities needs to be identified basis all these factors. Next step. So compliances, again, this is about the regulatory compliances, standard guidelines, and focus on OT OT compliances is on dedicated OT security policy, establishing a strong monitoring and controls, adoption of best industry practices, and adherence to the regulatory requirements for public health, safety, and national security. These are the compliances. Next slide. So these are certain standard compliances for the OT security. ISA IEC 62443 is one of the most prominent standard. All the products, all the networks, or the OEMs, they comply with these standards. And they build up the architecture. The architectures needs to be built up basis this. 62443 explains the requirements of the network architecture. It explains how the risk should assessments to be done. Again, at the same time, it identifies on what should be the software software development life cycle. So it takes care of all the aspects. NIST 882 to 853, these are the guidelines from this. ISO 27001, then again tailoring of lot of requirements in terms of ISO 27001 will be required. Probably like there are certain plants where encryption cannot work. So probably you won't be able to achieve it. So then you need to take care of all those things. There are different guidelines related to smart grids. CISA is again Homeland Security of United States. They clearly explain a lot of regular guidelines in terms of infrastructure security. NUC CIP is again a very prominent standards. And in India, we have NCIPC guidelines, which are for the critical infrastructures, and CA, they have released a guideline for power sector. Lot of other sectors are also working. Lots of things are going on within the organizations, within the industries, within the at the industry level. So as time will proceed, more and more stringent regulations and policies will come up in terms of compliances. So it is very important that we make ourselves ready and make ourselves ready for the future regulatory compliances. And it's not only about the compliances; it's all about the your business, your people who are working in your environment, the neighborhood. So OT security is very much important factor which needs to be taken care of. Is as one point it take care of the business, but take care of the people who are working into the environment. That's it. I think we don't have any more slide from my side.
Thank you so much, Chitrank. I was not wanting to hurry you up because there was some time I wanted to allocate to questions, but now that we have finished, I'd welcome any questions from the audiences. We've had very patient a set of audiences today, and I'm sure all of them had some interest in OT, and that's the reason one would sit through. So over to the audiences. Anybody can unmute and ask a question. Okay, we have one question, one hand raise. Could you please unmute?
Yeah, hi, Chidranjan sir, this is Somil from Seven Hills Cyberwall. I'm the owner of Seven Hills Cyberwall precisely. So I just wanted to know, we were talking about all the OT security part. So what is the provision of that particular data protection bill which is coming? How it may affect the OT sector precisely? Can you just highlight on that particular factor?
It's as if now, the focus area for OT is probably on the safety, reliability, and confidential safety, reliability, and the availability of the plant. So as we see in terms of data protection, so anything which is on the OT environment, I do not see coming as a part of that data protection. But yes, then there will be typical network architecture drawings which will be parked. Maybe as a practice, it is being parked in the IT environment. Those will be covered as a part of OT, as a part of the data protection environment.
I have a point here, Chitrang. I mean, it's a question actually. In terms of the medical industry, for example, when you're looking at MRI machines or any kind of medical equipment, which also has some data entered through the medical technicians, is that like a personal data of somebody, and through an OT environment, if it could get compromised, will that come under the law?
It's very difficult to say at this moment, but yes, if any kind of PII data is there, we need to see how we are going to secure it. Probably not. As of now, I do not have the right answer to it, but yes, if it is a PII data where some personal information, typically to the health and medical industry, it is there, then definitely something has to be done where for securing that particular data.
Yes. So adding to this, yes, if it's like EHR data, PII data, like patient data, because if you go to medical industry, right, and patient health data, those kind of things are there, and that's where the solution like IOMT, those kind of things comes into play, where you have to secure the data also. First of all, you have to secure the OT systems where the data is there, because they simply add the data and it stays there. But yes, you have to have defense in depth, all those things, then so that you don't expose the data outside. And even in certain condition, you can't expose the data to everyone, because even nurse might see different data and doctor might see different data, right? Those kind of classifications are also there, where all the data security controls, those kind of things comes into play.
So ideally, will have to understand that every OT environment is different. So probably one solution, one answer to each and every OT environment may not be the right. And we have to see, for example, a hospital or a pharmaceutical. No, so now both are related to health, but then when it comes to OT security, probably they will be having a different requirements.
Thank you, Chitrang. Pradosh has a question, and thank you, Pankaj, as well, for contributing. Pradosh has a question. He has a hand raised. Could you please say the question?
Well, on the same answer, I would rather like to add the DPDP Act actually says the business requirement. If the OT environment is actually collecting, recording, or processing any data which is related to personal identifiable information or any EHRs or PHIs, then this OT environment comes under DPDP Act. If it is not having any kind of high risk to the data subjects' rights, then this Data Privacy Act is not coming down to this particular page.
Got it. Thank you so much. Thank you. Soumya, you have a question as well. Please go ahead.
Yeah, it was a great session. Just I want to ask, like, how we can implement the SAR. Like you told that in CIA Triad we have, in IT security we basically use the CIA Triad, but in OT security we have to use the SAR. Can you give any example like how we can implement the safety, availability as well as reliability?
For implementing the safety, reliability, and availability, it's not about implementing. The point is, the focus is toward the safety, reliability, and availability. So when you are designing an architecture, you need to make sure that in a plant, for an example, in a plant, there will be a process automation system, and then there will be a safety SIS system. Now, safety SIS system's role is that is the final line of defense. In case anything goes wrong in the process, SIS system will take care and smoothly shut down the complete plant without affecting any machinery or human life. In case SIS fails and there is fair possibility of rupture of that particular mechanical device if it does not takes any mechanical action, for example. So when you design a safety architecture for considering SRA, so you need to segment this say SIS system in a different zone with the different kind of safety requirement, probably and then the process zones can be different. So the focus is on the safety, and as well as as I mentioned, when you are performing a risk assessment, you need to understand what kind of processes are moving into the environment. No, so it's not like you have a pump. Normally you have, or usually we have a pump set up in our home, and we switch on that pump and it goes, the water goes to the top of the tank and gets filled up. Now that is one small OT system with very less or no automation. That similar process can be very much critical, where the overfilling of the tank can result in the spillage, and then probably an HCl is passing through that particular tank. So now here the process becomes critical. So you will have to understand that particular process and tailor that approach, and then if required, segment it, create right kind of segmentation. You need to allow a limited people to enter into that zone. Access can be limited to certain or asset owners only. So all this is a focus area where you have to focus on all these aspects. Hope I could answer your question.
Yeah, that was great. Yeah, thank you.
So if there are no more questions, I think we could conclude the session. Thank you so much, Pankaj, Chitrank. It was very useful, and I absolutely appreciate the fact that you covered it in very in very detail, and people could, of course, sit through the session, and there was, I'm sure, fairly serious amount of information and knowledge that they kind of got out of this session today. So thank you everyone for attending and participating. Any Jyoti, do you want to say something?
I just wanted to add saying thanks to Chitrank and for taking this session, because it was very detailed and in depth. All the points that were to be taken care of in OT security, implementing the security, was covered. Thank you very much.
Thank you, Jyoti. Thanks, Pankaj, once again, and everyone else. Manoj was also there. It's just that he was, in transit. He couldn't have conversation today, but we all kind of are certainly more informed as of now. More informed than we were before the session. Thank you so much, and have a great day.